Good morning. Welcome to Purdue's Security Seminar. It's my great pleasure to introduce today's speaker, Dr. Marianne Winslett. She has been a professor at University of Illinois at Urbana-Champaign since 1987. Her current research interests include security in open systems and data management for high-performance parallel scientific applications. She was an editor for ACM Transactions on Database System from 1994 to 2004 and has been the vice chair of ACM SIGMOD since 2000. She received an NSF Presidential Young Investigator Award in 1989.
Great, thanks, Mingwei. Well, today I'll be talking about what we have found out about using trust negotiation in real-world settings. And this is work I'm doing with two students, Adam Lee and Charles Zhang, and also with some collaborators at other universities or other organizations. Jim Basney and Vaughn Welch work at the National Center for Supercomputing Applications, and they're associated with the grid security infrastructure. And also, I'm working with Piero Bonatti at the University of Naples and Wolfgang Neidl at the University of Hannover in Germany. So I realized that there are professors and students who do research on trust negotiation here. And in fact, I know that several seminar speakers in this seminar have talked about trust negotiation. So I didn't want to do a super long introduction about it, but not everybody may have seen the previous seminar, so I thought I'd do a little bit of a condensed intro. So trust negotiation is an approach to authorization that's for use in open systems. And by an open system, I mean a system where resources are accessed across organizational boundaries. And here's an example of how that might look. Suppose that Alice is an employee of Widget Corp. And normally she's based in California, but she takes a business trip to Widget Corp's office that's in Beijing. And then when she gets there, she needs to plug in and access local information and local data. Well, not just anyone can log on to the company's network. They have admission control. They check to see who she is before they allow her on. So before she can get on the network, she has to prove to the network that she is trustworthy. Usually that's done by typing in a login name and a password. And if she has this login name and password, that allows her to prove to the network that she's trustworthy. But there's no trust in the opposite direction. I mean, why should Alice trust this network? Does it have the latest patches? Are they running virus protection software? The trust is entirely unidirectional, and that's maybe a little bit scary. And then the next thing that's not very pleasant is that when Alice tries to log in, her identity isn't known by the local network's authorization server because she comes from a branch office far away. So she can't actually get on the network, even though in theory we know that it should be okay because she is an employee of Widget Corp. So there are various ways that we could solve this problem. For example, the Beijing office could in real time check back with the office in California and see if Alice is a legitimate employee, or maybe we could have some sort of distributed identity-based solution. But I think what will be more scalable for the long term and a lot easier to manage is if we base the access rights of Alice on the attributes that she can prove about herself and not on her identity at all. In this case, what's relevant is that she's an employee of Widget Corp, and that should be enough to get her initial access to the local network. So let's see how that might work. The Beijing office, maybe it's not going to let people from other branches of the company access every subnet of the network. Some things may be a little sensitive and private to the local office, but at least for very basic access, anybody who can prove they're Widget Corp employee should be allowed to get on the network. So Alice can prove this by showing that she's an employee, maybe some sort of digital employee ID, but then she may have her own restrictions. she may not be willing to present it to network authorization servers that don't have a certain patch levels, for example, patch level 4 or higher. So she may want the authorization server to prove some things about the network before she shows it her credentials. So the problem here is that on the Beijing side, the network manager has to know how to specify and enforce the local office's restrictions on resource access and usage. And Alice has to find out about Beijing's policies and somehow satisfy them while she's still enforcing her own access policies. Well, how do we solve this problem? Two pieces of the puzzle are, first, having a policy for every resource that Alice might try to access. that an outsider might try to access in this network. And for every resource Alice has that she might be willing to show to an outsider, such as this Beijing network authorization server. So that's the attribute-based access control policies piece of the puzzle. And another piece is trust negotiation, which is runtime software that will clients and servers can use to show that they satisfy each other's relevant access control policies. So let's look at an example of how this might work in this particular case. On the left-hand side of the screen, we have Alice's security agent, and it's running this TrustBuilder software that I'll be demonstrating to you later on today. And we've got some icons on the screen. That handshake is a TrustBuilder logo, and down below it we have a little picture of a TrustBuilder agent that I'll talk about later. And this security agent has access to various credentials that Alice owns and policies about who she's willing to show these credentials to. So if this is her employee ID, it looks like the access control policy that protects it is that she'll only show it to servers that have patch level 4 or higher. Similarly, on the Office Network Authorization Server side, they've also got a security agent. And this policy here says that if you want to get access to the network, you need to show that you are an employee of the company. And it has a digital certificate that shows it has patch level 4. Okay. So at runtime, the way this would work is that first, Alice tries to access the LAN. The authorization server gets her request and sends back the access policy for accessing the network. And that says that on-site access is allowed, but only for widget core employees. Next, Alice says, well, if you want to see my widget core employee ID, then you have to prove that you have patch level 4 or higher. And the network authorization server is willing to show that to anybody, so it sends it back to Alice and proves that it owns it by signing a challenge. Next, Alice is willing to disclose her employee ID because the policy for access to the employee ID has been satisfied. So she sends it to the other side and does a proof that she owns it. And then finally, the authorization server lets her access certain subnets of the LAN, whatever that particular type of user is entitled to see. Okay, so this is... Things to note about this are that first, it's an automated process. Second, it's iterative. The two parties slowly built up trust, starting with innocuous little things like I'm patch level 4 and working up to more sensitive information like I work for widget core. And it's bilateral. Each party got a chance to have its own requirements for trust fulfilled. So it's bilateral. Another thing that we can do with these facilities is that we can renegotiate trust later on. So suppose that Alice accesses the local network for a while and then she wants to go to a particular subnet that has, say, financial data that not just anyone is allowed to access. Maybe she has to prove she belongs to some financial department back home in order to see this information. At that point, we can renegotiate trust. So in this diagram, we've got step 1, we've already performed. That's when Alice first tried to access the network and ended doing, was sent off to do a trust negotiation with the authorization server. Later on, if she tries to access this financial subnet that has sales data, She'll again get referred to the authorization server. Trust can be negotiated again, and if she can satisfy this more restrictive policy, fine. She'll be given access to this additional subnet. Okay, again, key points, iterative, bilateral, and automated. We've just seen that you can renegotiate trust on the fly as needed as time goes on. And we also have ways that you'll see in the demo of protecting sensitive requests for resources and also for protecting sensitive information that's in policies. Okay, so what we've been, so in my early years working on this, I had a PhD student who was theoretically oriented, and we did theoretical work. That student has graduated, and with my current students, we're focusing on some more practical questions. Basically, we are trying out trust negotiation in various real-world situations and seeing what else is needed in the real world. So the area where we're furthest along is in trying out trust negotiation in high-performance computing grids. Since I come from the University of Illinois, high-performance computing is very important there, and NCSA, National Center for Supercomputing Applications, has high-performance grids right next door to our building. So I've been working with two people from NCSA, Jim Basney and Vaughn Welch, on trying trust negotiation out with the idea that maybe it could become part of the grid security infrastructure, which currently is just based on identity. It's not access control, it's based on identity, not on people's attributes. So the two main research directions that have emerged from that work so far are, first, we need a very graceful way of making trust negotiation available to all the things that are already on the grid and don't know about trust negotiation. And towards this end, we have built standalone authorization service called Traust, and I'll be showing you a demo of that in just a little bit. And with this standalone service, legacy clients and legacy servers can still take advantage of trust negotiation. The second direction we found is important on the grid is that you really need trust negotiation, as you've seen in our examples, it's between two parties. But in the real world, you often need to involve additional parties at runtime who want to help, who have useful information that you need, and you need to involve them in the process. So how to do this in a graceful way is the subject of our work on PeerTrust2, which I'll also talk about today. And high-performance computing isn't the only area where we've been trying out trust negotiation. We've also been looking at computer networks, like the example we used, admission control on networks, and also new research problems that might be posed by the way that people would use trust negotiation on the corporate intranets of very large companies. Okay. So I'll be showing three demos at this point. The first two are demonstrations of TrustBuilder, which is our software for runtime trust establishment. And what you'll be seeing is trust negotiation added to TLS. Okay, so by extensions to TLS's re-handshake facility, trust negotiation will be taking place on the fly as we access a website. And this demo is brought to you by my colleagues at Brigham Young University Internet Security Research Lab in Kent Siemens Group. TrustBuilder uses IBM's trust policy language and trust engine software internally, and you'll see how that fits into the overall agent on my next slide. The third demo that I'll show you is of Traust, that standalone authorization service that makes trust negotiation available for legacy clients and also for trust-aware clients and legacy and trust-aware servers as well. In that demo, the trust negotiation will not be running inside TLS. It will be running on top of TLS using something called the Traust protocol that I'll talk about later. And Traust also makes use of TrustBuilder and IBM's TE and TPO. So before I show you the demo, I'd like to just say a little bit more about what you'll be seeing in the TrustBuilder demo. Both the parties involved in this demo will be running these security agents. And the security agents have several internal components. Okay. The major internal components are shown in blue, these 3 blue boxes. And the simplest of those components is the credential verification module. And when someone gives, and this particular agent belongs to Alice, so when someone sends Alice credentials, for example, Bob, those credentials are checked by the verification module to be sure that they haven't been tampered with and the signatures really are by the person they're supposed to be by. Okay. And if they pass the verification test, they can be passed on, and they'll probably make their way down to this policy compliance checker, which can check to see if the credentials that Bob has sent satisfy any of Alice's relevant access control policies. Okay. This same module is also used in a different way to see if the policies that Bob has sent over to Alice, up on the top left corner, to see if Alice could satisfy those with any of her credentials. The compliance checker also checks for that. And then the negotiation strategy module is the brains of the outfit. It decides at runtime exactly what it should send to the other party next during the negotiation by making strategic decisions. Okay. So I'm going to bring up our first demo. So here I'm running an ordinary web client, except that I have edited the preferences so that I'm running a security agent. And that security agent is running as a proxy on this machine. Okay. All right. So let's cancel that because I've already turned on the proxy. And I'm going to go to a website that's being served by a web server that I started right before our meeting here began. So that web server is also running on my laptop right here. Okay. So this web server is running a modified version of Apache Tomcat that has a security agent built into it. And my proxy is going to act as my security agent. So we've got these 2 security agents, and they're going to talk to each other in the following way. So this website represents a wholesale pharmacy. It's a place that pharmacies can go to when their stocks are running low to buy additional drugs. So let's pretend for the moment that I work for one of these retail pharmacies, and I need to buy more stocks of one of these wonder drugs, say Ridicin. Down at the bottom, my credit card number is already filled in, and I can press the order button to order it. When I do this action, there are access control policies associated with it. We don't want consumers just buying any drug they want over the internet. So to buy from this wholesale pharmacy, you have to be a retail pharmacy, and that means you have to be licensed by the Board of Pharmacy. Okay. So in the background, you'll see a couple of windows. These are Java windows. And one of them is the window for the security agent for the client, and the other is the security agent for the server. And when I click on the Submit button, you will see them going back and forth, and you'll see the printout from the negotiation that's taking place in the background. So let me go ahead and click Order Now. So the negotiation was successful because I had the credentials needed to buy from the wholesale pharmacy. I am working for this retail pharmacy certified by the Board of Pharmacy, and I was willing to show them to the wholesale pharmacy. So this worked. But if we go back and try to buy one of these drugs that is marked as a nuclear pharmaceutical, let me see. The access control policy for that purchase is a little bit different because a pharmacy to handle nuclear drugs has to be certified in proper handling procedures. And you get that credential also through the Board of Pharmacy or a Board of Pharmacy who in turn is certified by the FDA. And my pharmacy does not have that credential. So when I try to order that drug, the negotiation will fail. So you saw the negotiation running in the background, and the outcome was that it failed because I didn't have the right credentials. Okay, so that's our first demo. And it shows how you can use trust negotiation to limit access to sensitive resources over the internet. The second demo is slightly different. We're going to be protecting sensitive access requests. And to motivate this, let me show you a piece of mail I got recently. If you're like me, you get dozens of these emails every day. This one is supposedly from eBay, and it says, due to fraudulent activity on my account, I really need to click on this URL, which looks like it's an eBay URL. And if we went there, it would ask for my social security number, credit card number, CVV code from the back of my credit card, and lots of other information. And they've made this URL. There are various ways you can do these tricks, but you notice that even if I put my mouse over it, if I were a naive user, I'd think, oh, this really is eBay. It's not just eBay, it's secure eBay. So I would be foolish and send them this private information. At least that's what they hope I'll do. So let's look at how trust negotiation could help prevent naive users from responding to those sorts of phishing attacks. Okay. So suppose that email is from the legitimate eBay, and they really do want me to go to this website and fill out all this private information like my credit card number, expiration date, CVV code, and so on. Well, my security agent has several policies in place to protect me from inadvertently disclosing sensitive information of mine to inappropriate parties. And these access control policies say, for example, that my credit card number should only be disclosed to companies that have, I think, a privacy policy and are members of the Better Business Bureau. And my eBay account name and password should only be disclosed to eBay as proven by possession of a certificate from VeriSign. So if I click Submit here, for the legitimate eBay site, the trust negotiation will succeed. You see it running in the background, because eBay has all the credentials that I was requesting, and it was willing to show them to me. So it's okay for me to disclose that information to them. But if I go to a site that looks exactly the same to the casual observer, asks for the exact same information, but this time it's not eBay, it can't prove that it possesses a certificate from VeriSign declaring that it is eBay. In that case, if we do the trust negotiation, it's not going to work because this site can't prove that it's eBay because it's not eBay. I think I have the appropriate windows hidden in the back. Is that it? Nope. I think maybe this one. No. I've got too many windows here to see the one we want. Somewhere in this stack of windows, there's one that says that the certain policy hasn't been satisfied. The policy for giving out my social security number hasn't been satisfied. The policy for sending out my eBay account name only to eBay has not been satisfied. And it asks me if I want to submit it anyway. And if my answer is no, then the trust negotiation will fail, and I've been protected from sending this information to this imposter site. But if I click on the yes, send it anyway, then we have an amusing ending to the demo, which I can't seem to find the right window for. I've just got a few too many of them here. I think this one actually turns off the phishing demo, but if I can't find the little arrow window, that's just as well. Yep, that's the one that concludes the demo. So I'm sorry you didn't get to see the very ending of that, but the screen that I'm looking at is about half the size of normal since it's being projected up on the big screen. Okay, so now let's go to our third demo, which is Traust, the standalone authorization server. And we start by starting up a Traust client. Pull up our Mozilla. Okay. The Traust client is very slow in starting.
While that's starting, I have a quick question.
Good timing.
You said that one of the policies you would have is that your eBay ID should only go to eBay.
Mm-hmm.
How does the trust negotiation software know that it's your eBay ID that you're entering here and not your Fisher's Anonymous ID?
Okay, it's scanning the content that goes past, and it's in this case, it's doing simple pattern matching techniques to look for what it knows is my eBay username and password. So if we were fancier, we could use arbitrary IR-style techniques to classify the content into different categories of sensitivity. So once the agent identifies that a certain type of sensitive information is present in the request that I'm sending out, in this case as part of that long post request, it looks up the policies associated with that type of sensitive content, and then it enforces them on the fly with the other party. And then if the other party can't satisfy them, it brings up the little override window that I couldn't find in my stack of windows. And you can choose to override it if you want, but certainly in the case of the phishing attack, that would not have been a good idea. So that's how that works.
Sounds to me like then I'm going to need to use a different user ID for every site.
User ID. The security agent knows who you're sending it to also. So that's part of the policy. So if you're sending your standard Chris Clifton login to one site, and even if you use the same password, it may be okay to send that without further negotiation, or it depends on who you're sending it out to. So that can be part of the triggering process. Okay. Okay, so let me quickly run us through this last demonstration. This is a one taken from the domain of disaster response. There's a phenomenon known as mass convergence. When a major disaster happens, people who want to help converge on that site where the disaster's taken place. And trying to coordinate those people and get them where they're needed and send the ones that aren't needed back home is a major, major headache for disaster coordinators. So one potential use of trust negotiation is in automating the process of getting the people with the right skills to the right places. So here we have a website that has pages inside of it for people from various different categories who might be converging on the site to help as volunteers. There are fire and rescue people, police officers, rescue dog handlers, structural engineers, and social workers. For each of those people, there's a page behind this home page that tells them where they should go, where they're needed, what they need to bring, all that other sort of information. But this particular web server is a legacy web server. Oh, and I should add, you don't want to give this information out to just anybody. So if you need rescue dogs to search through the rubble of this collapsed building, you don't want gawkers going down there and getting in the way and standing around. You want to get the volunteers where they're needed and not send people who are not needed to that place. So the information in this site is sensitive, and you want to get it to the right people, but only to the right people. So this is a legacy website, so the only thing it has protecting it is a password. And obviously a volunteer who's coming in, let's say a volunteer rescue dog handler, they don't know the password. They don't have an identity on this site. This role they're trying to authenticate to, rescue dog handler, they don't know how to do it. So in this demo, what we've set up is this website has delegated the task of giving credentialing and giving out passwords to a Traust server. So the Traust server, this is a Traust client. The Traust server is running on a machine back at Illinois, Rose. And to trigger the trust negotiation, all I need to tell that server is what role, what resource I'm trying to access. In that case, it's the home page for rescue dog handlers. So as I toggle between these roles, the home page information at the bottom changes. So if I copy that over to this Traust client and start a negotiation, in a little time it's going to come back, because I do have the right credentials, and we'll talk about what those were in just a minute. It's going to come back and tell me this really secretive looking password called handler password. And then I can use the handler password to log into the website. And yes, I got into it. Here's the information for search dogs and their handlers about where they need to go, what they have to bring with them. There's no water, you have to bring water. Report to the staging area, here's where the staging area is, and so on. Okay, so here we have a legacy server and also a legacy client, because I ran that Traust thing by hand, and we're still making, being able to use trust negotiation to establish trust on the fly. So the thing that's interesting about this demo is that the policies are actually extremely complicated, and we'll go back to the PowerPoint and talk about what was happening in the background that we didn't see during the demo. Okay, first, Traust has the same ability that we've seen in the case of TrustBuilder to protect sensitive information and access requests. And as we'll see on the next slide, that was used in this rescue dog example. We'll see how it was used in just a minute. So if Alice decides that the Traust authorization server is trustworthy enough that she's willing to tell it what resource she wants to access, then the second step, the second phase, I should say, is that she actually tells the server what resource she wants to access. In this case, the home page for rescue dog handlers. And the way Traust is set up, a single Traust server could protect just a single web page or a whole enterprise, a whole set of web pages. So it's very flexible as to the granularity of protection and the number of resources it's protecting. Then an ordinary trust negotiation takes place to make sure the client is authorized. And if that trust negotiation shows that the client is authorized, the client gets one of these legacy-style credentials that it can use to access the resource. And in the demo, it was a login and password, which is really very old-fashioned. It could be something more modern, like an X509 proxy certificate. It could be a Kerberos ticket, a SAML assertion. Anything like that would work. The Traust server can give anything like that out. And it could be a credential that Traust has previously stored, like it's already got the Kerberos tickets and just waiting to give them out, or it could generate them on the fly if we don't think that that's too dangerous. So what happened during the demo? Here's the rescue dog handler, Alice. She's got various credentials and policies, and so does the Traust authorization service used by DisasterNet. Alice was a little paranoid, and she wasn't willing to tell just anybody that she was going to access this disaster site. She's only willing to talk about the fact she's a rescue dog handler to sites that are certified by a U.S. state as being a disaster response coordinator site. So this whole process starts by Alice telling that policy to Traust. Traust is one of, the the website that Traust is protecting is one of these official disaster response coordinator sites, and it's willing to show that credential to anybody. So it sends it back to Alice along with a chain that shows that that credential is issued by the state of California, which really is a state. Next, Alice says, okay, well then I trust you enough to tell you that what I really want to access is the rescue dog handler role. Okay, and in the little pop-up call-out, it's the details of what that request looks like. Well, there's a kind of complicated policy for rescue dog handlers. First, you have to have a search team credential that's issued by a certified search organization. And one of those is the American Rescue Dog Association. I actually don't know what NDSDF is because my student's a much bigger dog buff than I am. You also have to have a driver's license to prove you're over 18. They don't want very young people searching for bodies in the rubble. The driver's license has to be issued by a U.S. state. You need to prove that you have a valid tetanus shot by showing a record that's issued by a board of health that's certified by a U.S. state. And you have to prove that the dog has had its rabies shots. So that's pretty complicated. But Alice is willing to show her search team credential to this Traust server because she already knows it's a disaster response coordinator site, and she's willing to show her search team credential to any disaster coordinator site. But the medical records, she's not so forthcoming about. She'll show it to a government agency, a department inside a state in particular. And for her driver's license, she wants to know that the site she's showing it to adheres to some sort of privacy policy that's been certified by somebody. Well, this particular site does have that privacy policy credential, which it got from Trustee, and it is part of the state of California. It's willing to prove that to Alice. So Alice is willing to send to Traust her medical records and the driver's license and the dog's rabies shot information. And then finally, after all that, Traust sends Alice the password that she needs to access the rescue dog handler. So there's actually a lot going on in the background, and it's really nice that the user didn't have to deal with this directly at runtime. So the protocol that the software entities were using to talk to each other during the demo was on top of TLS. TLS was the transport layer. The protocol is a lot like the MyProxy protocol that's used in the grid security infrastructure. It's a very simple protocol where people send commands to each other and they get back responses. And in our case, there are only 4 important types of commands. There's a get info command, which you can use to get metadata about a server. There's an initiate trust negotiation command, and then the negotiation goes on until you send a end trust negotiation command. And as part of the negotiation, you may say what resource you want to access, and that's the resource request command. So a very simple protocol wrapped around TrustBuilder software. Okay, so in the remainder of the talk, I'm going to shift gears away from these demos and how to have trust negotiation with legacy services and talk about some harder trust management issues. Okay, so to motivate these, let's look at an example. So Alice has a company that makes some of its resources available to outsiders, but not just to any outsiders. So her issue is that she has to specify her restrictions on access to these resources, and we've kind of seen how to do that with the demos that we were just looking at. But she wants to do more. If she gives out information to some client, she wants to be able to tell the client what it can and cannot do with that information. In other words, she wants to control what happens with that information after it leaves her hands and goes off out into the internet. Well, that's pretty hard to do in the general case, but there are many scenarios where the client would be willing to follow her policy if she just had some way of explaining it to them and making it easy for them to satisfy the policy. And the reason many clients are eager to do such a thing is that there's been a lot of recent legislation that requires companies to have and enforce these types of policies, to track information as it flows through their organization and be able to certify that it's handled in an appropriate manner. So we've got a lot of clients who would cooperate if there was just some way for them to understand what they were allowed to do and not do with information and who they were allowed to send it to. So that's Alice's new issue, usage and redissemination conditions. And then on Bob's side, there's some things that he would like to do that he can't do right now. Sometimes whether or not you can get a service or get a piece of information depends on why you're asking for it. The purpose to which you intend to put that piece of information. If Bob had some way of describing his purpose of asking for information, maybe Alice would be willing to respond to more of his requests. Okay, so that's the first red item, purpose. And also, how can Bob find the credentials that Alice wants from him at runtime if he doesn't already have them in his possession? Is there some sort of broker he could go to or that Alice could tell him about that would help him? Or maybe he's got one of those credential wallets back on his home computer. How can he make the trust negotiation somehow involve his credential wallet back at his home computer? Okay, and how can Bob control what Alice does with the information that he discloses to Alice during a negotiation? So, for example, maybe he shows her his driver's license. That doesn't mean he wants her to just do anything she wants with it, like publish it in a marketing database. Maybe he should have some way to impose conditions on its future use. For example, yes, you can do what you want with it as long as you send me an email notification of what you're doing. Or no, you can't use it for marketing purposes. Those types of policies. And finally, how can he limit what information gets pushed to him? Sort of like a spam filter. Okay. So to rephrase these requirements a little bit more technically, Alice needs some help to meet her legislative requirements and corporate requirements. She needs distributed and scalable trust management, both for her legacy and her trust-aware services. And she needs ways to specify and reason about purpose of access, intended use, control of access, which we do know how to do, release policies, which govern who she's allowed to release certain information to, and redissemination of information after it leaves her hands and goes on to someone else. Well, Bob wants all those same abilities, plus he wants exposure control to limit the information Alice pushes to him and help in figuring out how to satisfy Alice's policies. So the research that we're doing that addresses these problems is called PeerTrust2. There is a PeerTrust1 that we worked on earlier when we first started looking at these issues. After maybe a few false starts, I think we have a really good solution approach, and we've named it PeerTrust2 to distinguish it from our earlier work. So PeerTrust2 is a logic-based framework for specifying purpose-based access, release, redissemination, and exposure control, and also for explaining how you could make use of helpful third parties in distributed systems. PeerTrust2 allows you to reason about all these ingredients at once. PeerTrust2 has a formal semantics, it has a proof theory, and this slide says it has an efficient runtime system, but actually it doesn't. That's not true. PeerTrust1 has an efficient runtime system. PeerTrust2 doesn't have any runtime system yet, so we've been working on the theory of it. So down at the bottom of the slide, there's a little diagram that shows how the situations that PeerTrust2 is intended for. We've got a bunch of peers, maybe offering services or being clients of services. The peers have a network that connects them, and inside each peer, the major parts are there's some sort of back-end knowledge base of policies and credentials, rules and facts. And when this peer communicates with other peers, there are filters that restrict the information that they can send to her that she's willing to accept, and there are filters that restrict what she sends out to other people. If we look at that in a little more detail, Here we've got our three peers, Alice, Bob, and a little kid. And they can send messages back and forth to one another. And each of them has a knowledge base with the same basic structure. This knowledge base is layered. The bottom layer is first order, well, modal. It's modal, first order formulas. Looks a lot like Datalog with some modal operators thrown in. The layer above it, release policies and proof hints. That's second order. We'll look at examples of that in a minute. The release policies talk about what information Bob is allowed to send out to other peers. So anything in his base policies he can reason about locally, but some of the things he can reason about locally, he's not allowed to send his conclusions out to other people. Okay. So the release policies govern what he's allowed to send out. His proof hints talk about if he wanted to find a certain credential or prove that somebody has a certain property, here's where he should go to try to prove it or to find that out. That's what the proof hints are. Exposure policies limit what can come in and what can go out. That's especially important for kids and for spam control. And finally on top, there are event condition action rules that determine what types of queries Bob is willing to accept from other parties and what kind of answers he gives to those queries, how helpful he is or how uncooperative he is. Okay. So let's see. I think today I'll probably just talk about the base policies because the demos take a variable amount of time. They took quite a bit of time today. So maybe on a return visit I could talk about PeerTrust2 in more detail. But today I'll talk about the base policies. And to start us out, in the blue boxes, starting with the large blue box, we have an example of base policies written in the PeerTrust2 language. It looks a lot like Datalog, except for these signs and L signs that are thrown into the Datalog formulas. If we threw out that part of the formula, it would look like a normal fact, student of Alice, and a normal rule. X is a student if X is a student. Not a very interesting rule, but a rule nonetheless. So the new ingredient that we brought to this mix is this idea that formulas can be signed, directly signed or logically signed. And the intuition behind a signed fact, like registrar signs student of Alice, is that somewhere there is a physical signature that the registrar put on that fact. So the registrar actually cryptographically signed student of Alice. So it's a non-repudiable. If you receive this signed thing in a message, you can check the signature and you know that the registrar really did say that Alice was a student. That's the intuition behind signs. The intuition behind L signs is a little bit different. Oh, I'm sorry, one more thing I want to say about signs. If the formula that okay. Let me do L signs first and I'll come back to signs. Okay. With a logical signature, for example, if we have registrar L signs, student of Alice, that means that we have a proof that would convince anybody that the registrar really would sign student of Alice. In particular, that proof shows that registrar L sign student of Alice follows from directly signed facts and rules. Okay? And so here in these two blue boxes is an example of such a proof of a logically signed fact. So here, Alice is probably a student at the University of Illinois. That's what this says. University of Illinois logically signs the fact that Alice is a student. Okay? And in our example, Alice is going to make use of this to buy books at a discount. That's always a popular example in trust negotiation. So what Alice has on hand when she starts out are the things in the upper box. Registrar signs student of Alice, so she's actually got a physical signature that the registrar said she was a student. And she's also got this rule that the University of Illinois signed. And the rule says that X is a student if the registrar L signs the fact that they're a student. So this is the University of Illinois' way of delegating authority about who is and isn't a student to its registrar. So you can see how it looks like you could almost just apply modus ponens here by plugging in this fact into the body of the rule, applying the rule and having UIUC assigned student of X pop out the other end, but not quite, because this fact doesn't exactly match the body of the rule. One has signs and one has L signs. Fortunately, we have some rules to help us out. And the first of those rules says that if you've got something with one of those direct physical signatures on it, then you can conclude from that you have something that the signing party would also logically sign. If they'll physically sign it, then they certainly are willing to logically sign it. So from registrar signs student of Alice, we can conclude registrar L signs student of Alice. Oh, good. Now that matches the body of that rule pretty nicely. Okay. And we have an extended version of modus ponens that works when the bodies of the rules have signatures in them and when the rule as a whole is signed, so that we could produce the conclusion that UIUC logically signs student of Alice. Okay, so this looks a lot like ordinary Datalog and ordinary modus ponens with just a few ingredients added to it. Okay, and I'm going to show the example that runs around the edge of this slide, and then I'm going to stop for today. So in this example, the bookstore gives a special discount to University of Illinois students. Illinois delegates the task of student identification to its registrar office with that formula that we saw earlier. The registrar office pushes to Alice a digital student ID. Registrar L signs student of Alice. And Alice can use the combination of these facts. If she can figure out where to get them, she can present these signed things to the bookstore, and the bookstore will conclude just what she did, that the University of Illinois says that Alice really is a student. And then the remaining things that I'm not going to be able to talk about today are, how the heck does Alice get all this stuff? How does she know to go to the registrar? What makes the registrar willing to answer her questions, or why would it push those facts to her? Questions like that are handled in the upper layers of PeerTrust knowledge bases. Okay, so in conclusion, let me flip past the explanations of the higher level stuff, which aren't for today. And in conclusion, I think that automated trust negotiation is interesting both in a theoretical sense and also as something potentially very useful for today's open systems where resources are accessed across organizational boundaries. So I hope I convinced you that there are a lot of interesting theoretical and systems issues that people can work on, and many of those issues haven't been touched at all yet. And right here at Purdue, you have Ninghui Li, who works on this exact same topic. And so if you're interested in learning more about trust negotiation, just go and talk to him during his office hours. Thank you very much.
Thank you.